Good morning. Today we are discussing on solubility product. So, what is solubility? Solubility is the degree to which a substance dissolves in a solvent to make a solution. Okay? Degree to which a substance dissolves in a solvent to make a solution. To make a solution. Okay? Or we can write grams of solute per liter of solvent. Grams of solute per liter of solvent. Okay, so solubility depends upon two factors. First one is lattice enthalpy. Lattice enthalpy. What is lattice enthalpy? Lattice enthalpy, and second one is solvation enthalpy. These are the two factors which determines the solubility. First, lattice enthalpy. What is lattice enthalpy? It is the measure of the strength of the forces between the ions in an ionic solid, or we can say is the binding force between the ions in an ionic solid. Measure of the strength of the forces. Strength of the forces between the ions in an ionic solid. So, greater the lattice enthalpy means the forces between the ions will be greater, or stronger will be the force between the ions. Now, second one is solvation enthalpy. What is solvation enthalpy? It is the enthalpy change. It's the enthalpy change when one mole of a substance dissolves of an ionic substance dissolves in water to give a solution of the infinite dilution. So enthalpy change when one mole of an ionic substance dissolves in water. Okay, dissolves in water to make a solution, to give a solution of infinite dilution. Infinite dilution. These are the two important factors which determines the solubility. Now, for a salt to dissolve in a particular solvent, what will be the case? Solvation enthalpy must be greater than its lattice enthalpy. Okay. For a salt to dissolve in a particular solvent, dissolve in a particular solvent. In such a case, what will be the case? Solvation enthalpy must be greater than its lattice enthalpy. Okay, solvation enthalpy must be greater than lattice enthalpy. Lattice enthalpy. So, if solvation enthalpy is greater, which means the lattice enthalpy may overcome by the solvation enthalpy. Okay, so the salts can easily dissolve in that particular solvent. Now, according to the solubility of different solids varies. Depending upon that, solubility are categorized into three. Now, let us discuss these three categories. So, three categories. First category, soluble salts. salts which are soluble. In such a case, the solubility is greater than 0.1 molar. Such salts are soluble in solvents, in water. Okay. Now, second, slightly soluble. Salts which are slightly soluble. Slightly soluble salts in which the solubility is between 0.1 molar and 0.01 molar. So, 0.01 molar. Solubility between 0.01 molar and 0.1 molar. Such salts are slightly soluble. Okay. Third category, sparingly soluble salts. Sparingly soluble. In this case, the solubility is less than 0.01 molar. Solubility less than 0.01 molar. So, here we are discussing about this sparingly soluble salts. In such case, some salts are undissociated, some salts are undissolved and will remain in the solution. Here, here we are discussing the salts which are sparingly soluble and their solubility product. So, sparingly soluble salts examples. Sparingly soluble salts. Examples are barium sulfate, then AgCl, PbCl2, etc. are sparingly soluble salts. So, in such cases, some of the salts are undissociated. So, undissolved salts are present and also the dissociated ions are also present in the solution. So, a dynamic equilibrium is established between undissolved salts and ions in the solution. So, dynamic equilibrium is established between undissolved salts and dissociated ions in the solution. Okay, dissociated ions in the solution. Now, take an example in the case of AgCl solid, equilibrium established between the ions Ag plus and Cl minus. So, by the law of chemical equilibrium, we know the equilibrium constant K will be equal to the concentration of Ag plus and concentration of Cl minus, the products, divided by concentration of AgCl. Okay, or we can write K into concentration of AgCl equals concentration of Ag plus into concentration of Cl minus. Here, in this case, AgCl is undissolved salt. So, the concentration of this undissolved salt is a constant. So, K into a constant will be equal to concentration of Ag plus and Cl minus. So, this constant is known as KSP or solubility product of the salt. Okay, this is equal to, so solubility product of the salt will be the product of the concentration of the ions present in the solution. Okay, now we can explain solubility product. So, solubility product, this is a solubility product. So, solubility product is defined as the product of the concentration of the ions. Okay, concentration of the ions in a saturated solution. Okay, in a saturated solution with each term raised to the power. In some cases, there will be stoichiometric coefficient. So, product of the concentration of the ions in the saturated solution with each term raised to the power equal to the number of times the ions occur in the solution. Okay, raised to the power which is equal to the number of times occur in the equation. Occur in this equation. Okay, occur in the equation. Okay, occur in the equation. So, solubility product is a product of the concentration of the ions in a saturated solution with each term raised to the power equal to the, which is equal to the number of times. This stoichiometry represents the number of times the ions present in the solution, okay, in the equation. So, number of times occur in the solution which are representing the solution, the equation representing the dissociation of the salt. So, this is important. This is the solubility product. Now, let us take few examples and explain how the solubility product determines. Okay. First example, BaSO4 dissociates to Ba2 plus SO4 2 minus. Okay. This is the first equation. Here there is no stoichiometry. So, KSP, solubility product. How can we calculate solubility product? It will be the concentration of the ions. Okay. Now, second type, PbCl2. Next example, PbCl2. In this case, Pb2 plus 2Cl minus in this case. Okay. In this case, what will be the solubility product? Here, stoichiometry. So, 2 Cl minus ions are present in the equation. So, concentration of Pb2 plus and Cl minus whole raised to 2. Okay. So, with concentration term raised to the power, the number of times the ions present in the equation. Okay. This is the case. Now, third type, calcium phosphate, Ca3PO4 twice in this case. What will be the equation? 3Ca2 plus 2PO4 3 minus. This is the next equation. Okay, in this case. So, solubility product KSP will be equal to concentration of Ca2 plus whole raised to 3 into PO4 3 minus whole raised to 2. So, this will be the solubility product of Ca3PO4 twice. Now, in general, how can we write this? In general, if the salt is AXBY, this is the salt, and it gets dissociated XAY plus, okay, plus YBX plus X minus, okay. So, this will be the case, okay. This will be the case. Now, how can we write this solubility product? So, solubility product will be equal to concentration of AY plus. This is the positive ion raised to X, okay, into, this is the negative ion, BX minus whole raised to Y. So, this will be the solubility product. Like this we can calculate the solubility product, okay.